Okay, I'm doing this video, I better turn that down a little, mostly just to prove that I'm not effing around here. This is a 1 watt signal, okay, into VK5, alright. Now I've been experimenting non-stop. I did finally get to sleep last night though, yay, and I'm playing with transients, okay. My terminology has to differ from general ham radio talk because I'm taking a fresh look at everything and playing with things in a very different way. Now, that is quite literally a 1 watt signal, okay? But I'm experimenting and figuring out how to get longitudinal displacement currents along a single wire and then create transverse electromagnetic waves at the other end to become an antenna. And I'm also playing with in types of inductive systems, well, basically dielectric and magnetic inductive systems to bring up the voltage peaks. But I'm now managing to actually get as much along this longitudinal wire as possible. So I'll just go into camera mode, right? So this is the coil arrangement, okay. I'm just going to jump across. Now it's messy in here. I've been in mad scientist mode. So we got the cable going here to the ATU. We've got cable from the ATU down here, wheeling across straight to the radio, okay. It's on charge USB, which means it's only giving me 5 watts, but I'm actually running 1 watt. M1 is my clear text for my 1 watt, and you can see there, okay, that's 10%. all right, so I'll just show a little bit more. So I'm running 1 watt. Now my rectenna there isn't lighting up, so what's good about this is, see, there's bugger all, very little, that's a little tickle coming off the ground reference side of things. So virtually bugger all on the common mode side. This inductor, in the right conditions, takes any back EMF and adds it to the forward EMF. Its output is going to this inductor, which is similar but also a voltage step up, but it doesn't have its own return path to the original circuit ground, okay? It then has a single output to a single wire electric fence tape. Now, it's very easy, by the way, for the longitudinal wave coming along here to duct off in the wrong direction. So, for example, I've lifted it here, and you'll see, you know, getting a reasonable signal off that. Then it drops back to ground, and then this little rectenna system allows a path up to its, you know, differences up above. So, you know, it's lighting some lights. This is attracting it down to this point. If I don't do this, sometimes it will just loop back because it's a transient to the transceiver itself. Then the longitudinal conductor just continues on all the way. I'll just come around here. Right. Just, yeah, across the garden. Seriously, it's a mess out here. Along here, and you can see nothing coming off that, right? And it comes along here. Oops, camera's got to come back on, sorry about this. And then it takes a trek up that tree. So I think I've disrupted the path of the filament there, but there you go. So you can see the antenna, that's 1 watt, is transmitting a TEM wave. Well, I'm seeing the electric fields looking at it from this way, but there you go. So I'll just jump back to the SDR. Oops, silly thing. And I'll go back in. I see it's dropped down there. I'm going to just try and redirect, make sure I direct that So there's my filament down this way. So that's how it's working. It's basically an infinite impedance. So with an infinite impedance, the forward currents are equal to the reflected currents when they're at resonance. And so that means there's no coherence in the rotating magnetic fields. They're cancelling each other out. But there is coherence in the electric field line, basically the vectors. So I'm really figuring all this out. It's very exciting. And I think there's a hell of a lot I can do with this. But yeah, there's 1 watt. And just back to the transceiver. Yeah, so no silly buggers here, okay. But I know some people won't believe me, because the conditions are pretty rough. And there's me saying it's a 1 watt signal. I'll stop now, and I'll change my power to 5 watts, which is about 50%. Sorry, I didn't have that in shot very good. Oops. Yeah, alright, 50%. And M5. Alright, and back to the, oops, stupid phone. Back to the SWR, I mean SDR, geez, I'm tired. So there you go, there's QRP 5 watts now, into VK5, using that electric fence tape as my transmission line and antenna. But there you go. So that's actually quite nice. Fantastic. So yeah, lots to experiment with. Yeah, so I think a lot of it's now playing with the transients. I think if I dedicated a room, for example, I could probably turn that room, see it's changing as I move around in the house, into a passive amplification system. I'm actually nutting this out. I can actually see how it can be done. 7-3, and thanks for watching.